Alright guys, welcome to our channel Code with Sunny, and today we will be discussing the hard problem cherry pickup second. Its index is 1463. Okay, so you can see over here I've already bookmarked this question to my favorite list. You can see also I need to suggest I need to mention it about that I've already solved this problem, right? Like I've solved this around 16th of August. Okay, and I don't know, yes, I have solved it for practice, not for the daily LeetCode challenges. Okay, so now I have wondered that I would be solving right now. Let's see how I can solve this one. Okay, so let's begin with understanding of this problem. We have been given rows into columns matrix representing a field of cherries, like every cell would be denoting some value, where grid of ij represents the number of cherries that we can collect from this particular cell. Okay, and we have two robots that can collect cherries for me. Robot 1 is located at the top left corner and the robot 2 is located at top right corner. You can see over the diagram over here, that is the robot 1 is present in the top left corner and robot 2 is present on the top right corner, and from here the robot is going to start to move. And there are some of the constraints that is being given to us. Like from a cell I comma j, robot can move to the next cell, like to moving from row number I to row number I plus 1, and for a particular column j it can go to 3 columns for the next row. You can see j minus 1, j and j plus 1. Okay, like if you consider the diagram I've already made, if the robot is at over this position, then he or she can go to there or there or there. Okay, there are three possible ways, that is moving to the next row, and there are three possible ways to swap, like to go for the columns. And like if it is at here, it can go to this one or this one. Okay, so there would be three possible ways for the columns and there will be only one possible way for the row, that is moving to the next row. And when any robot passes through a cell, it picks up all the cherries that is present in that cell and the cell becomes an empty cell. Okay, when both robots stays in the same cell, then the only one take the cherries. Like suppose this robot is present over here and the robot wants to move to this position. Okay, and there's another robot over here and this robot also wants to move to this position, and if it occurs, then we are going to increment the number of cherries being picked up by only one parameter. Okay, someone is calling me, let me see. Okay, let me pick up it later. Okay, so we are going to pick it up only one time. So suppose the value present over this is a and this robot wants to move to this one, it will, our number of cherries will be incremented by plus a. Okay, and when this is over here and this one wants to move to this one, then it should also be incremented by a, but this will not happen because when the first robot comes to this cell, it has picked all those cherries and the number of cherries has become empty, so the a value of a will become 0. So when the second robot comes, then there will not be any cherry, so there will be no increment in the values of total number of cherries that we are going to pick up. Okay, so let's move on to the next constraint. Let me raise it up. Okay, so both robots cannot move outside the grid at any moment. This is like an obvious constraint. We cannot move any robot to like outside the grid, and both robots should reach the bottom row in the grid. Okay, now this is also important. You can see that this is like both robots should reach the bottom row in the grid. There is no constraint in the columns, like the robot can end up to this one or this one, or the robot can end up to this one or to this one, or both the robots can end up into the same cell in the bottom row. Okay, so what we have to return is what is the maximum number of cherries collection using both the robots by the following rules below. Okay, so we need to maximize the number of cherries being collected. Okay, so what I've initially thought about this problem is like this the first robot is over here and the second robot is over here. Okay, so I guess many of you have also wondered the first of all the greedy solution, and the second one you have been wondering about the like simple DP. Like I will explain it out, simple DP, what does it mean over here. And third one would be like yeah, that is it. So greedy would be like when you are at this cell, you would be looking for all those cells where this robot can go, and you will go to that cell which has the maximum value. Okay, maximum value. Okay, suppose here it is, let's say 10, and here it is 15, then you would be considering the 15 as the optimal move. Okay, then how do you move both the robots at a time? So that should be quite tricky. Okay, and here also you would try to move to that cell which has the maximum value. Okay, that would be the greedy part, and I am 100% sure that greedy part will not pass all the test cases. Okay, because actually I have like drawn some examples and I have understood that part. Okay, and another part would be like dp, simple dp. I have mentioned it over here, simple dp. Okay, so wait a minute. Yeah, where it is, let me just connect this one. uh, where is my pen? Okay, so wait. Yeah, so the first one was the greedy one, and the now it is being about DP. Okay, so like, see, I've talked about simple DP. So what does simple DP implies over here? Simple DP is like you are going to perform the moves first for this robot and followed by like for the next one for the this robot. Okay, and how do you track the movement? Like there can be the possibility of this movement. Let me just explain. Suppose the robot is over here, this is the first robot, and the second robot is over here, and this robot will try to move over this position, and this robot will also try to move over this position, and you have to consider the value present in this cell exactly one time. Okay, so this should be quite tricky, because when you perform all the moves for the first robot, only for the first robot, that is moving this robot to the bottom row of this grid, and whenever the this robot will reach to some of these cells, let's say this one and this one, then you will make the value present at these cells as 0. Okay, and then you will try to move to this, move this robot. So this is not an optimal way to solve this problem. There might be some case like you would be tricked, and let's consider this case, like suppose you have 2 2 2. I'm not getting some exam like case like an contradictory case to prove my point, although I'm taking this one. Let's say 1. Okay, so let me just choose this color. So suppose the first robot is at over here and the second robot is over here. So the cherry picked up is 2 for this robot and for this 2 this robot. Now the next move you are going to consider for this robot, first robot, would be like checking out the maximal position. And like the next move will what will the next move will maximize the total number of cherries. You can see it will be, it is coming out to be here 100. Okay, now for this cherry for this robot, the next maximum move would be like going to this cell. Okay, now you would be wondering that yes, my answer would be like 2 plus 2 plus, you can see this cell is visited, should be visited exactly one time, should be 100. So you are saying that my answer would be 104. If you're considering some greedy approach, then you are going to do like that. If you're considering some DP approach, where the first robot will complete all the moves, then followed by the second robot, okay, then you're going to get 104. But can you think that 104 is an optimal answer? No, obviously not. So the optimal answer should be, like for the first robot, it should move to this one to this one and this one to this one, like second robot would be moving to this one to this one. Okay, you can see the moves are optimal. So the my answer would be like 2 plus 95 for the first robot, and for the second robot 2 plus 100. So the total sum would be like 102 plus 97. Yeah, I think I am right. So it's like 199. So this should be the maximum number of cherries being picked up. So how do you track these all these data? Okay, so the very optimal way is to use dynamic programming. Dynamic programming. Okay, so what are the states of dynamic programming and how we are going to perform the movements efficiently? Okay, so let me move out to the next page, and okay, so how, let me just explain. I will be writing down a 3D DP where you can see the every time each robot is going to move to the next cell. Okay, so anytime we are going to have the data of the particular row number. Okay, so I would be writing now DP of n. There should be maximum. You can see the row number, and the first data would be like m, and m third, like second data would be m, and third data would be m. Like I'm mentioning out the maximum size. So let me write down, in general case it would be like dp of I j k. So dp of I j k will denote maximum number of cherries maximum number of cherries up picked up till now, where the robot 1, what is the position of robot 1? Position of robot 1 is I comma g, and position of robot 2 would be what? I comma k. Okay, so this will be the our dp state, and I am going to explain the both the approaches, top down approach and bottom up approach. So let's try to write down a top down approach, dp, top down dp. So I will explain it out while coding it up, so it would be best to understand the dp state and all the moves, okay, and how to maximize the answers. Okay, so let's move out to code to the coding part. Okay, so let me just copy it, and I will use my editor, it will be best. Okay, I hope you guys can see my screen. So what is the maximum size of the matrix I can have? Note that I have also not explained the movements, like taking this example. I have seen many of the videos of the other YouTubers. They will explain the like test cases. I think this is the kind of waste. If the problem is like straightforward and you can understand through these examples. Okay, so I hope you guys must have understood the problem till now. That is, this robot can move over this one and this robot too can move over this one, and you need to consider the case like for a particular cell, if both the robots are meeting at the same time, you need to consider it for the only one, like the value present at this cell should be considered only once. Okay, you can understand through these examples. I have been focusing on the concepts. Okay, so maximum size is what? Maximum size is like 70. So let's take a dp of size, for the best case I can say would be like 75 would be for the row, and the other two data would be for the column, again the 75 part and again the 75 part. Okay, so let me set then down the default value of this dp, so size of dp. Okay, and let me write down the grid size, and column would be like grid of 0 dot size, and let us solve for the initial positions of the robot. Okay, so I will write down passing the parameter grid, like the details of this grid, storing the values, and the initial row number would be 0, and what is the column number of the robot 1? Column number of robot 1 would be 0, and column number of robot 2 would be like m minus 1, you can see over here. Okay, and we need to just solve this function finally. So I would be writing down the details of the grid, so vector int, and would be the details of the grid, and what is my current row r, and current position of the robot 1 would be c1, and the current position of robot 2 would be c2. Okay, what would be the case when r reaches the value of n? So we would be returning the 0, like total number of cherries being picked up when this r exceeds the total number of rows. Okay, so where n is like grid dot size, and m would be like grid of 0 dot size. I'm not sure. Yeah, although I can write like this one. Yeah, so if r reaches n, return 0. Yeah, what would be my next case? I would be using the memoization part, memoization, like using the, like if I have already solved for a particular state of dp, I'll be using that value. If dp of r c1 c2 is not equal to -1, then I will say return dp of r c1 c2. So I will write down state already solved. This state of dp is already solved. And okay, so let me write down current cost. If like robot 1 is present at r comma c1 and robot 2 is also present at r comma c2, so if c1 is exactly equal to c2, so I should have to take the value exactly one time. So I will write down grid cost would be r c1, and if c1 is not equal to c2, then my current cost would be like grid r c1 and plus grid r c2. Okay, so this would be my current cost. Okay, and I need to find out the answer for the current state. Okay, So what I will do is like okay. So let me fill out this value would be like I need to traverse for the like next moves would be like all the three positions of the column. So I would be like difference would be d1 would be -1 and it should go up to less than equal to 1 and d1 plus plus. And for the second robot would be difference would be starting for with -1 and it would go for d2 less than equal to 1 and d2 plus plus. Okay, so what is my new column for the I plus 1th row? Like that is R plus 1th row. So I would write new col 1 is like C1 plus D1, and again new col 2 would be like C2 plus D2. But new col 1 and new col 2, which is the new data for the columns, should be within the range of this grid. So I will write min of new col 1 and m minus 1, and again new col 1 should be max of new col 1 and 0. It should lie within the range of this grid, and I need to write down one thing also for this column 2 also, like new col 1 would be the new column for the robot 1 and this should be for the robot 2. Okay, so what is my current maximum answer would be max of yeah, max of answer and current cost plus solve, like I need to solve for the next state passing the parameter as grid, and note that I need to move to the next row number and new column 1 and new column 2. I think the details are quite correct. Yeah, and after doing this I need to write down dp of rc1 c2 as my answer, and like storing the current state answer, and I'm going to return this one also. I think this should work. Let's save it and let me run this code because I'm not sure about that. Yeah, wrong answer. So let me just figure it out where this wrong answer has been appeared. So n is grid dot size. Let me just start with the base one. Grid size, grid zero size. Okay, so what I've done it. Okay. Oh no. Grid size, grid zero size, passing zero. The second. Yeah, this is correct totally. So if r reaches the end, it should be 0, and r c1 c2 should be not equal to -1. So this state of dp is already solved. So my current cost would be RC1 plus RC2 if C1 is not equal to C2, right? Okay. And again, you can see my answer is 0. So D1 is -1 and D1 goes up to 1 and difference goes up to plus plus. Because from the current cell, I need to go from like J minus 1, J and J plus 1. That's why I'm doing -1 to 1. So this one is also correct, and yeah, the new column 1 would be like minimum of new column 1 and m minus 1. Okay, and new column 1 should be max of 0 again for the new column 2, and I need to solve for the current cost plus what are going to the r plus 1 and going to new column. And yeah, you can see I have done some foolish mistake. It should be new column 2, right? Okay, I think yeah, it should accept it. So let me just submit this code. Yeah, I'm not been like assuming that it should pass. You can see I've solved quite after quite bit long time. So there is also a bottom up approach also where we can solve this problem. So let me just open my past submissions where I think I have solved using a bottom up approach. Yeah, here it is bottom up approach. So I will not waste your time to like see only my codes being typed, and so I will explain my bottom up approach right over here. So in the case of bottom up approach, what we are going to do is like the two robots will end up into any cell for the last row. Okay, right? So we'll be filling up the values for the last row, last data, that is dp of n minus 1. You can see for every columns I and j. You can see if tp of n minus 1 I and j, I am filling it out as grid of n minus 1 and I. Okay, so if c1 is exactly equal to c2, so this value should be filled only one time, and if it is not, I will be filling exactly one more time. Okay, and I'd be filling from the from the n minus 2 to exactly 0th row. Okay, so it should be traversing every possible c1 and c2, and you will just move out. You can, from the current cell, you are going to have three possible ways to move for the columns and exactly one possible ways to move for the row, that is going to the row minus 1, and for the particular j you can go from go to j minus 1, j and j plus 1. Okay, so this is being exactly done. You can see now c1 is going to vary up to this one, and now c2 is going to vary up to this one. Okay, so each time I'll be finding out the maximum value and adding to the current cost, and finally returning the state. Note that you are going to end up with 0th row, and the first robot position will be 0 and the last robot position will be m minus 1. So this would be your answer. Okay, so if you guys have any doubts, so you can reach out to me through a comment section of the video, or there are many possible ways to reach out to me. So if you have any doubts, just tell me, I will just solve it. Okay, so thank you for watching this video, and don't forget to subscribe.